This is the ancient rainforest of northern Australia. It's home to one of the largest birds on Earth. We're here to explore why this mysterious animal has been called a living dinosaur, and to find out why it's regarded as the most dangerous bird in the world. But we won't find one up here. This monster lives down on the ground. We've come to Australia to find a rare creature that looks more like a velociraptor than a bird. Its call can be heard for miles across even the thickest rainforest, although they're notoriously difficult to find in the wild. They can be taller and heavier than a full-grown man and are armed with 5-inch talons that have actually killed humans. We're going to investigate the prehistoric origins of this bizarre bird, the cassowary. But first, we hope to see one on Queensland's Cassowary coast. Biologist Simon Watt's going to search in the heart of the jungle. Anatomist Joy Reidenberg's going to try the beach. And I'm following a lead further inland.
I'm in possibly the oldest rainforest on Earth. It's older than the Congo, older even than the Amazon.
Is the knife in case the cassowaries get too close?
No, definitely not. It's a cane knife and just
effective.
North Queensland equivalent of a machete.
I'm with Peter Solaris, a tropical fruit farmer who's lived all his life alongside these birds.
How do you spot them among all this undergrowth?
There you go. See that track there? That's before the last rain event. You can see another footprint there. So the bird's gone up and come back. So I don't know which was first, but it's had rain in it.
There's one somewhere around here.
Yeah, there's one somewhere, yep.
The jungle is so dense that they could be a metre away and you'd still not see them. Unfortunately, I found nothing but tantalising footprints.
I can't believe it, it's right there. Wow. A wild cassowary just walking right in front of me. This is really unbelievable. Keeping my raincoat out in front of me in case it decides that I'm a threat. I feel like a matador with a bull, because these birds do have some notorious weaponry on their feet. Okay, now I'm a little scared. That was too close.
A few miles down the coast, I'm going to a place where cassowaries stray out of the rainforest into suburbia. Jenny Cameron's invited me to her house to experience a close encounter. Hello, Mum. Wow. So what's the story?
He comes here and sits under the tree there and sits there all day.
That is extraordinary to see her kind of through your kitchen and
yeah, it's a safe
sink
place
and you're
to
washing
be.
up. And
yeah, I wouldn't like to be on the outside doing this. They do sneak up on you.
That must have scared the living daylights out of you, didn't it?
It does frighten you a little bit. Yeah, I've been filming them sometimes and not concentrating properly, and they've actually come up and tried to take a little piece of the camera.
Look here, there she comes.
Oh, here she is.
Here she comes.
And this is Bella.
And a little chick behind her. It's amazing, isn't it? I've flown halfway around the world to see cassowaries in the wild, in the rainforest. And where do I see one? In somebody's backyard, right outside their kitchen window. Cassowaries are endangered. In recent years, 2 huge cyclones have destroyed large areas of their habitat. With the rainforest flattened, they enter towns, searching for food. Here they're increasingly vulnerable to road accidents. Half of all recorded cassowary deaths happen on roads. There are now only around 1,500 left in Australia, so each death is significant.
Seriously injured, this endangered cassowary was never going to live. Struck by a motorist along Bramston Beach Road near Innisfail, a local vet was forced to euthanize it on scene. With the car travelling at 80 kilometres an hour, the 60-kilogram bird didn't stand a chance.
The Queensland Parks Wildlife Service collected this bird shortly after it was euthanased. It was kept frozen for us so we could investigate the anatomy. Wow, that is a monster bird, isn't it? Oh, there's its broken leg. That is so sad. Let's leave it there to thaw, because that's going to take a good 24 hours or more to thaw out, isn't it? After it's thawed, we're going to dissect the cassowary to uncover clues that will help us trace this bird's evolutionary story. Carrying out our dissection right here in the middle of the rainforest at the Rangers station, and we're joined by Graham Lorreton, who's a cassowary expert, a vet, and the first thing we need to do is to get as much data as we can, but it's also a great opportunity. Just look at this thing. It is clearly a bird, but it is massive. We've got a beak and a pretty kind of obvious bird head at this end, but look at the colour of this neck, then this massive monstrous body that's got feathers, but it looks more like hair. Look at these kind of spiky quills sticking out. Moving down to the iconic part of this bird, these incredible legs, which do look as if they've come off some weird, enormous reptile, don't they? But here is the obvious injury that was the cause of death. I mean, it's not a hope in hell of repairing it.
Any injury like this, it's a death sentence.
You think we can take this off and examine the foot up a little more closely?
Sure.
You can probably just cut it right here.
Try and get through the skin there, I reckon.
How tough is that skin?
It's pretty tough.
A little tension, maybe we'll get right through here.
What are your first impressions of that?
Velociraptor? I would say this looks like a dinosaur. It's a hell of a big chicken foot.
Yeah.
It's tough and leathery and scaly like a reptile, with a nice, serious weapon on the side here. Let's just see how big this foot is compared to mine. So here we've got the toes, the foot, this is the heel, and this is the ankle here.
Plonk your ankle on top of its ankle.
Oh, right.
Ankle to ankle. There you go. Your toes,
That's a fair comparison.
reach the fracture line.
That's about it. So its foot is twice the size of mine.
But this foot isn't just something to stand on and get you about, is it?
Oh no. So you can see this dagger here is to defend itself. Maybe if we can go onto the intact leg here. So when a bird is feeling threatened, they use it as a dagger, almost in like a forward karate kick motion. It will then just jab. Yeah.
Presumably, this movement is when it's jumping at you. You've got fully flexed like that.
Yep.
That then goes.
Whoa!
Straight out. Exactly.
Straight at
Look
it.
like arrows coming straight out.
Exactly.
We've got a melon down there. Let's just see if that claw would go into a melon if you
give it
held
a try. You'll see how ripe the melon is.
Wait, you want me to hold this?
Okay,
Yeah,
you hold it. I'll show you
go.
how far it'll go because I don't want to hurt you. This is going to go to about there.
Okay.
Yeah.
You got it.
Okay.
You ready?
Right. Okay.
Yep.
1, 2, 3.
Oh, you got it.
Stick in.
Yeah, so it goes straight through. Or a fair way in
that.
there.
And it'll be quick. I mean,
It's
you
quick,
wouldn't
yeah.
react in time to get away from it.
I'm glad it was not my belly.
How you going, mate?
Not too bad.
Nice to meet you.
Yeah, you too. I'm looking forward to meeting your cassowaries as well.
Yeah, they're looking forward to meeting you too, mate.
How many have you got here?
It's my job to meet the animals.
Henry's the small one, Henry's the aggressive one.
I've come to Johnson's Crocodile Park to find out why cassowaries have earned their fearsome reputation.
Yeah, make you a bit nervous. They are slightly intimidating looking when they're like that. This is not the natural order, being frightened of a bird. It seems the wrong way around.
You got to watch out for them flanking us. They're very, very smart birds. A cassowary can actually go around the back of you when you're not looking and run up behind and kick you. So you always got to be aware of everything around you. You can run away from crocodiles, they're fine. These guys, they chase you. The previous owner of the farm here actually used to use a hat to cover his face when he was getting too close to him. So he's just grown a natural disliking of hats.
Wow!
I'm lucky not to have experienced the darker side of these birds. There are stories of cassowaries attacking zookeepers. This footage shows just how dangerous they can be. When threatened, the cassowary will lash out, kicking and slashing with their razor-sharp claws. Cassowaries have broken legs with the power of their kick. They have even killed humans.
Joy's eager to uncover the anatomy of the ferocious kick. A few strokes of her scalpel and the leg's off. That is one very, very heavy leg. Are we going to take this apart a little bit and start to see some of the biomechanics of this and what's going on?
Yeah, let's finish taking the skin off so we can actually see the musculature that's involved.
Watching this with some interest is Scott Hockmanall, who is a paleontologist and dinosaur expert. People call these living dinosaurs. Is that because of this, Scott?
It's fantastic. I mean, if you think about without the feathers and you just extended the scales up onto the leg, people would just think this is a dinosaur leg. I mean, that's the fact is, it is a dinosaur leg.
Yeah, at first I thought it was just this plump because of all the feathers, but now with that off, I see it really is huge.
He's a monster.
Heavy.
Right.
And look at the size of these cables. These tendons are enormous. Why don't we take a closer look at this? We can clean this out a little bit and then pull on it.
If we shrunk down and actually blew up a velociraptor, we would get the same proportions. It would look identical.
This side is the extensor, the Achilles tendon. It's going to pull the ankle open. But closing it is going to involve tendons on this side that are pulling it up. So they pull on the extensors. Look at that. You can see the toes coming out.
Just twitching. It's kind
Look at that. That's amazing, isn't it?
That's amazing, yeah.
So those are extending the toes just by pressing on that tendon, like a little marionette, pulling on the strings. And if we pull on all of this together, it should bring up the ankle joint.
So yeah, you should.
Yes.
If you, Graham, pull on that lot and you pull on that lot at the same time, this will fly.
You better watch out over there, Scott. There we go. Ready?
1, 2, 3.
Shoots it straight out. Yeah.
So it's the muscles on the front of the calf as well as on the back that are both contracting at the same time to get that full extension. What we're seeing in front of us are the ingredients of a hind leg that are almost identical to what you would have seen if you were dissecting a dinosaur millions of years ago. It's incredible to think this bird is expressing dinosaur DNA from its past in its T-Rex-like legs. Surprisingly, cassowaries will eat meat too. Throughout their bodies, there's plenty of clues that birds are descended from dinosaurs.
Open up its wing.
This thing's freaky.
Isn't it?
Calling
the
that
weirdest?
a wing? That's the
It's a strange wing, but have a look at this.
There's not much there.
It's a little reduced wing, but on the end of it is a claw.
The claw is a vestige of a dinosaur forelimb.
So why don't we cut into it and see if we can see the structure of it. A little tension right there. Pull. Good. Perfect.
There you go.
So if you separated that from this animal and you just put that in front of somebody, you wouldn't call that a wing, would you?
I wouldn't know what to call that.
You ain't going to get off the runway with that.
No.
It is so peculiar. I mean, these quills, you think they do have a function, even if it's a kind of bit of a sideline?
So they obviously don't use them to fly, they don't use them to flap around, but they do certainly use them to help protect themselves as they go through the rainforest. You actually see the vines and the thorns slip off them as they're walking through the dense rainforest.
So let's have a look inside this.
You'll see the same structures in this humerus as we find in theropod dinosaurs.
When you say a theropod dinosaur, what kind of dinosaur are you talking about?
Well, they're the meat-eating dinosaurs, everything from T-Rex to Velociraptor.
So that's the elbow joint.
Just like that.
Humerus, radius and ulna.
And that claw is that?
That's right, it's probably off the middle finger, so that one there.
That one there.
Yeah.
Okay. The genetic link between birds and dinosaurs is becoming increasingly clear. Until recently, it was thought dinosaurs were scaly, reptile-like monsters. Then, in the 1990s, scientists realised something amazing. Dinosaurs had feathers.
Dinosaurs are proverbially extinct, but actually the dinosaurs didn't go extinct. Dinosaurs flourish today as birds. The evidence was available in the time of Darwin in the form of a historic fossil, Archaeopteryx. It had feathers like modern birds. It flew like modern birds. It had a general build like modern birds. But it had a long bony tail. No modern bird has that. It had teeth in its jaws. No modern bird has that. It was halfway between a modern bird and what we think of as more traditional dinosaurs.
Archaeopteryx is the missing link between birds and dinosaurs. All birds descend from this flying dinosaur.
You know, the earliest birds had feathers, but what we don't know is exactly how they first took to the skies. There are two main theories. One, that they were tree dwellers and leapt and glided from branch to branch. The other, that they were ground-living species which ran and used their forelimbs to take off. Something we can still see today in chickens. Hey, go on, go on. When chickens run, they flap their wings for balance, for traction, sometimes for flight. Perhaps the earliest attempts at flight looked something like this.
To understand how the first dinosaur bird took to the air, we're going to have to look for clues in the wings of a bird that can fly. This is the heaviest flying bird in Australia.
So this is called a bustard, it's called a plains turkey.
Look at the size of these wings.
He's a big bird, obviously they do fly as well.
Okay, so here's the other wing. So we're talking like that orientation, so humerus down there, radius and ulna that way. So these extraordinary quills and this very feathery hair-like, they're so radically different to this.
Absolutely, this is the intriguing part. These bits, these quills, look just like the flight feather quills from the bustard.
So this part right over here.
That's right, if you lost all the little fluffy bits, you just basically end up with a quill. So that's really great evidence to show that these guys had an ancestry that were flying, because these primary feathers are the main feathers used for flight.
When you look at this, you have all of these parts of the feather that are sticking out here. And when they're all seamed up together, it makes one nice uniform plane, kind of like an airplane wing.
That's right.
These are the barbs. Those barbules are so tight, it's really hard to split it. But there we go. So now we're just seeing one individual barb. And off of that, if you look really closely against it, and you really need a microscope to see that well, are the little tiny hooks, the barbules.
Under the microscope, the structures of the barbs become visible. Moving in closer, we can see the tiny hooks that hold each barb together like Velcro.
If we take that single barb and we let it flow back in line with its friends, all I have to do is push that together, and the little hooks of the barbules seam it up, and now...
From an engineering point of view, that is beautiful, absolutely beautiful.
Let's take a look at the cassowary feather, which is completely different. When we put that feather down and look at it against this white background, we notice that all of these little barbules are not together. They're not seamed up like they were here. So you don't have that planar form where you can now actually get lift. Everything's going to flow right through this, like it's got holes all over it, basically.
When you look at the fossil record of feathers, they start out as very simple single barbs, just basically like a duck down covering of these dinosaurs, but then they start to evolve more complexity right up to the flight feathers.
Feathers alone weren't enough to fly. To create lift, birds had to flap their wings. So should we look at the muscles that actually power flight to be able to get this thing off the ground?
We should start with where we first cut the wing off, which is right here. There's the joint where the arm was, and then this is the breast area, the part that you would eat on a chicken. But unlike chicken breast, look how dark this meat is. It's much more in a sense like duck meat. Chickens aren't great flyers, but ducks really are. And when we open this up here, what we're seeing is a massive amount of this muscle. It takes up this whole area, right down to the very front of the bird's chest. The other thing to notice is when we pull these muscles completely away from the bird's chest, is we see a really interesting bone sticking out here. This is like the keel on a sailboat. All of this is providing extra surface area for that muscle. This is all bone.
Flying birds have evolved a specialised anatomy for flight. A large keel-shaped sternum provides an anchor for the 4 chest muscles. The 2 smaller of these muscles lift the wing. And the huge breast muscles power the downstroke. These attach to elongated arms, which are hollow to reduce weight. And the whole bird is covered in aerodynamic feathers, which make birds such graceful flyers. When birds first evolved from dinosaurs, they could fly. Somehow, the cassowary lost its ability to fly, and we want to find out why.
Here, Graham, if you can just pull that back there. You know, immediately I noticed there's quite a big fat layer on this animal. I didn't notice that on the buster. There's a huge amount of fat here.
So these guys get really fat. You get up to a few inches of fat between skin and sort of flesh underneath. If the season's good, if there's a lot of food around, they'll get 2-3 inches of fat, especially over this front part of their body. And that's obviously another reason why they have no chance of flying whatsoever, because they're big and heavy.
So the only thing I've seen that resembles muscle is this tiny little bit right over here. You know, I wouldn't think I was even cutting into a bird looking at this. You know, when you cut into a bird, you expect nice breast meat, you know. But there's just nothing happening here. This tiny little wimpy thing. This is it.
So this is
that's it. So if we pull this down.
Is this all bone here?
This is all bone.
And no keel?
No keel. No, none at all.
This is what I've just dissected off the bustard. So that is the flight muscle of a bird that is a fraction of the size of this.
That's right.
And so scaled up, if this needed to fly, this muscle would need to be out here somewhere.
Massive.
Absolutely enormous.
You imagine how long the wingspan would be in a bird this size if it could fly?
Just huge. This is a bird that's come out of the tree. It doesn't need to fly anymore, and the only bit that's really left to show that it evolved as a flying animal is that.
Little wing. That's right.
One tiny, tiny little wing.
The wonderful gift of flying is deep in the DNA of birds. They are ancestral flyers, and yet there are many birds, of which the cassowary is one, that has only a tiny little wing. They've lost their ancestral wing. Why did they lose the ability to fly? The reason is they arrived in a place where they didn't need them anymore. There aren't predators there, for example. And flying is expensive. It's a wonderful thing to be able to do, but it costs an enormous amount in energy, in huge breast muscles. And so when you can do without flight, it can be better to do without flight. The breast muscles shrink, the wings shrivel up to these tiny vestiges.
We've seen how the evolution of feathers and wings helped dinosaurs take to the air, but flight requires other adaptations. The muscles that flap wings have huge oxygen demands. We want to look inside the cassowary to see whether it's retained the turbocharged breathing apparatus needed to power flight.
Okay, I'll just get the rib cutters.
Okie doke.
and I'm just going to try and see if I can just go through each one. Okay. Yep. The animal breathes in, the air goes straight down into all of these air sacs, which are all through the bird. There's an air sac there, and they're everywhere. When you actually go looking, you find a lot of these sort of little membranes.
So these are not where oxygenation is taking place,
No,
right?
it's just like a balloon inside the bird. They just fill up and then let go of the air again as it goes back through the lungs. So the air goes into them, and then as it breathes out, the air goes back through the lung tissue. The blood, as it flows through the lungs, gets that oxygen out, and then the air goes back out.
To power flight, birds adapted dinosaur breathing into a highly efficient multi-stage process. Balloon-like air sacs fill over 60% of their body. When they breathe in, air passes straight through the lungs to the rear air sacs. Breathing out then moves this fresh air into the lung for oxygen exchange. A second breath in moves the used air to the front air sacs. And a final breath out releases the used air from the body. This means new and used air never mix like they do in our lungs. It's why birds breathe much more efficiently than us. The air sacs that aid breathing provide another unlikely clue to the cassowary's past.
These air sacs are paired, so you have some on this side?
Yeah, sure. So what you can see here are identical on the other side. They join in these ribs that we cut earlier. You can see they're hollow. They're not hollow because they've got bone marrow in them. They're actually hollow because the air actually goes down into those even.
So these air sacs actually extend up into these hollow spaces?
Into the hollow spaces, into the ribs, yeah. Through a little hole
like
there.
This?
Exactly.
The air sacs penetrate the skeleton throughout the body. They enter through tiny pores in the bone wall, filling the space inside with air.
This is a major feature of dinosaurs. The theropod dinosaurs that led to birds all had hollow bones like this in their ribs, in their vertebrae, all through their skeleton. T-Rex had them, Velociraptor had them, Australovenator from Australia had them. They all had these hollow bones. But of course they weren't used for flight. They were used to lighten the load. So although flying birds are thought to have these air sacs and hollow bones to help them fly, which is actually the case, a flightless bird like this still has the hollow bones. It's because of its ancestry. It's a theropod dinosaur.
To find out what else our big bird has in common with its ancestors, Scott's taking Simon to see a dinosaur.
You're going to meet Banjo. He's 100 million years old and he's the most complete meat-eating dinosaur ever found in Australia.
Wow.
Well,
this is what he would have looked like.
This is what he would have looked like, this fantastic head with these great sharp teeth, big arms with big claws and these massive long legs. So you can think of a cassowary with these massive long legs and claws. More terrifying than T-Rex and Velociraptor. Now when we look at a cassowary's ribs, they look absolutely they're just so similar to Banjo. So here we go. There's the rib.
Same shape again.
Exactly the same shape. Now the feature that we found in the cassowary was they were hollow because they have this pore. Now this pore is where the air sacs enter into the rib, making them hollow. Well, lo and behold, there's the pore in Banjo's bones.
So why does a dinosaur want hollow bones?
Well, they want to be light as well, but for a different reason. They want speed, they want to be a hunter. So they need a light load so that they're not spending as much energy when they run down their prey. If you were very heavy, you'd expend so much energy just trying to get speed. When we dissected the cassowary, I was seeing structures that I'd only seen in Banjo. So this is a skeleton of the cassowary. So we'll take the middle foot, for example. This is a phalange from the foot, the middle toe of Banjo. And here we have the same bone from a cassowary.
Oh, it's spooky almost to think.
It is.
It's exactly the same shape, it's just a question of scale.
It blows you away to think that these animals are separated by 100 million years, yet their toes are absolutely identical.
About 230 million years ago, the dinosaurs split off from the rest of the reptiles, and then they flourished mightily through the so-called Mesozoic period, which was brought to an abrupt end 65 million years ago with the famous mass extinction, probably caused by a meteorite or comet colliding with the Earth. Only 2 groups of dinosaurs survived that catastrophe, both of them birds, and they have given rise to all the modern birds that we see.
The 2 surviving groups of birds have very different numbers of species. One has only 6 species. It includes mostly non-flying birds like the cassowary. The other group is gigantic. It includes nearly all the 10,000 species of flying bird alive today. Both groups evolved a highly sophisticated way of communicating. A dazzling variety of complex sounds.
G'day, Buck. How are you? Pleased to meet you.
Really good to see you. I'm meeting with cassowary keeper Clay Mitchell, who's hoping one of the big birds will sing for me.
The boys are always generally a little bit smaller than the girls. This girl here is actually a big girl.
Okay, can I give her some of this by hand?
Oh, of course you can. It's like feeding the kids McDonald's. Everything gets swallowed whole.
Here you go, do you want that? It all goes down the same way, doesn't it? It's just a pick, chuck, gone, isn't it?
Down.
Absolutely incredible.
We feed that twice a day, 2 kilos in the morning, 2 kilos in the afternoon.
I gather she's quite a talker as well.
Yeah, she can boom. Actually, if we sit back after giving a little bit of a feed, she might actually give us a little bit of a boom for us.
Okay, well, she's had a good half of that, so let's leave that for now. Should we just perch over here and wait?
Right,
okay.
yeah.
And it can just be spontaneous, just
Yeah, basically. There's no real given rule as to why or when she actually does it, but it's definitely just sort of say, I'm big and I'm bold and I'm beautiful. Cassowary style.
That is some call.
Oh, look, you definitely feel it. You don't just hear it.
Absolutely. It's not just what you hear. Inside, you can almost feel yourself vibrating in sync with her. It is an incredible noise.
Oh, it's the deepest baritone you've ever heard.
It kind of vibrates inside you. It's awesome. If you didn't know one of these was out there and you heard it, you were walking through this forest, it would scare the shit out of you.
Give it some tension there.
Do you want to do that? Joy's interested in how low-frequency sounds are made in her whale research. She's keen to take her scalpel to the cassowary's windpipe to see how it makes that boom.
Okay, so now we're pulling this out from there. Let's bring it around here past the esophagus. So the air is coming in through the nose here, going down the throat, down in this windpipe or trachea, till it gets to this point where the pipe actually splits and one goes into the left lung and one goes into the right lung. Most birds do their songs from a series of valves that are located down here that are different. And this double set of valves can actually create more than one sound at the same time. You get one from one side and maybe another restriction on the other side, so you can get 2 different sounds generated. So what I'd like to do is cut this open and see if the cassowary has the same structure as other birds that sing. And already what we can see here is something that's vastly different than what you see in a mammal. It looks like there's 2 drum heads in here, one on this side going down this main pipe and one on this side going down that main pipe. These 2 drum heads are seamed up against each other when these 2 pipes are closed. But in addition, the part where it comes together is actually quite rigid. So what we've got here is something that really will stay open, allowing the vibrations to pass along here. Now, in a songbird, they have a relatively short neck. They still have this, they still make these sounds. But this bird has a relatively long neck. So I'm wondering whether the length of this pipe in some way relates to the lower frequencies. Kind of like looking at a pipe organ. The longer your pipe, perhaps, the longer the sound resonant space it's using. I think what we're looking at is something that could make a vibration. It could certainly make a fundamental frequency.
I've heard one of these guys boom, and it's something you will never forget. And what we're seeing right here in front of us is the anatomy that allows that to happen. It's got these kind of drumming membranes to create that very low frequency. It's got a very long trachea, which can be the amplifier, and the whole thing's powered by the respiratory system, which is essentially a huge set of bagpipes. One anatomical feature that may help radiate the sound is the strange structure that sits on its head, the casque. Its purpose remains an enigma. This horny growth on top of its head is a kind of iconic part of a cassowary, and very dinosaur looking, isn't it?
And it's the thing that everyone talks about when they say they've seen a cassowary. You know, they see that big helmet on the top of the head. The classic thing is people think it's hard. They think it's like a rhino horn or something solid.
I mean, it's very spongy and it's not hard at all.
When we squeeze it, you can see that it's soft. It's quite soft. It's a hollow structure. It's not solid at all.
Can we have a look inside it?
Sure, let's go for it.
And Graham, I mean, what are the various theories for the
Sure,
purpose?
so there's a few. The helmet idea, I think we can quite simply disprove, you know, it's not a protective structure. When they go through the bush, they do sort of put their head down and go, and maybe it just helps part the way a little bit, but it certainly isn't protecting them from predators or anything like that. The second theory is like a resonance chamber. When they're making that deep noise, does it help amplify the sound? The theory that I probably tend to think towards is more of a showing off type structure. You know, I've got a big cask, so I'm better than you type thing.
Like a crown?
Yeah, like mine's bigger than yours, exactly.
Every cask is a unique shape and size. Perhaps cassowaries use them to recognise one another when choosing a mate.
This is looking really weird. It looks like
peculiar.
Looks like
it's looking like one of those scourers that you clean your kitchen pans with.
Exactly. There's air there, but there's blood vessels, and there's this delicate sort of structure going through it as well.
I can't figure out what this is. It is such a weird anatomical structure. It's soft here. It's crunchy over here. It's got practically nothing here.
Yeah.
That's the skull right there.
Brain cavity below that. Yeah.
But wait. There's a hole here. That seems to be a hole right there. It's heading down towards the nose, away from the ear. And then there's another hole next to it right here, but I can't seem to get this tool into it.
No one's done any research at this part of the anatomy. This is a first for anybody.
It's extraordinary that this animal is so poorly understood, but we are now beginning to start revealing some of the mysteries of this incredible bird. For such a huge, colourful bird, the cassowary is still shrouded in mystery. No one even knows how many are left. David Westcott collects the DNA from cassowary dung to estimate the population size. Cassowary dung contains the unique DNA fingerprint of the bird which left it. By collecting and analysing each sample, David can work out how many birds live in any one area. His investigations have also revealed the cassowary's key role in the life cycle of the rainforest. Do they tend to lay them anywhere as they're feeding? Or?
Wherever's convenient. Aha, here you go.
What? You got one?
Yep, just up here.
Wow.
Yeah.
That's one big turd, isn't it?
It is, it's a thing of beauty.
The number of seeds in here, in terms of if all of these germinated, in terms of new growth, new plants and keeping the rainforest alive, this is one really important turd.
That's right, that's right. A lot of these seeds will germinate.
And this is the piece of the jigsaw that just tells you how reliant the rainforest is on the cassowary.
That's exactly right, yeah. Look at this. This is what? This is an old cassowary poo. So,
oh wow, look, you've got actually germinated seeds
that's right,
here.
that's right. When they eat the fruit, a lot of the flesh of the fruit gets turned into a pulp, and that's all disappeared. And washed away or degraded, and now we're just left with the hard seeds that remain. Yeah, and look, they're splitting open, and
and this is the beginning of new rainforest.
That's right. Well, hold on. Listen. What?
Oh, wow. Getting very quiet in here. Look, about 4 metres away. David's just spotted this. A wild cassowary. We are literally 3 or 4 metres away. It's feeding, it's picking up what look like tiny, tiny bits of fruit. It's such a dramatic scene, isn't it? This incredible bird in the rainforest. It is just the perfect scene. But it's time to let him or her be. It's almost impossible to tell the difference between males and females. The wattles that dangle from the throat are thought to play a part in luring a mate, but even they don't enable us to tell the sexes apart.
We'll just try and pull all this out if we can. Just cut down through there. And you can see out the other side, and there we go. That's what I thought it was. This. Okay, what do we go?
I know what this is.
Okay, we've got eggs.
It's a girl.
We've got an ovary there. We've got an ovary with what have we got? Follicles here.
Wow,
we've got
look at
one,
loads of them.
2,
Look at all these.
3, 4, 5 big ones.
The size of the ovaries reveals that our cassowary was a breeding female.
This bird was hit in sort of August, September, which is the breeding time for these guys. So she would have been out looking for a mate, getting her eggs ready. When they're fertilised, she's obviously going to lay those eggs.
The female will mate with a number of males and then lay between 2 and 5 huge eggs. Next, something extraordinary happens. The mother abandons the eggs and the father takes over.
The male will sit, and he sits on those eggs.
Hang on, so she just then says, "Thank you very much, done my job, I'm off." You, oi, sit.
Yeah, exactly.
That's a wife.
That's called nagging.
It's a single dad from then on. He does all the work.
The cassowary dad is left to rear the kids, from baby chicks to young adolescents.
In fact, the interesting thing with the female is not always are the eggs that she lays for that male, not all of them are his. She might mate with a male down the road. She might mate with a male over the hill.
That's outrageous.
And he'll sit on them. He'll raise them. He'll grow them up, and he'll go. And he doesn't really even know if they're his.
When they reach maturity, the male leaves them to fend for themselves.
Fascinatingly, there's some evidence that some extinct dinosaurs, including Tyrannosaurus, did the same thing, because fossils have been found that appear to be males associated with eggs. So it would be wonderful to think that this ancient method of reproduction has been preserved from dinosaur times in cassowaries.
So Tyrannosaurus rex was the kind of ultimate dad in terms of a role model for bringing up the kids.
Well, for them, yeah.
That's shocking. Scott's taking Simon 600 kilometres inland to Lark Quarry, where a remarkable set of fossils is preserved. They show one last similarity between dinosaurs and the cassowary.
Well, welcome to Lark Quarry.
Wow, that's...
It's phenomenal, isn't it?
It's like the outside inside.
So this is an absolutely unique set of dinosaur footprints. There's nowhere else in the world that you can see these, because it's a 15-second snapshot in time. But I'll paint you a picture of what this place is like. Imagine you're standing on the edge of a billabong and it's drying up, and it's left this big flat mud flat. So it's completely open.
Yes.
There's a group of dinosaurs, about 150 of them. They're all congregated around the water's edge, and they're all about the same size, from chicken-sized to about the size of an emu or a cassowary. Something startles them, and they all start sprinting in the one direction, obviously getting away from something.
And do we know what that something was?
Well, we do have some footprints that might help that out. Let's have a quick look and we'll show you. So we come up to this side of the trackway, And
Is that it?
Yes, that's
Are you
right.
serious?
Well, there's not just this one. Look, if you look out to the end, here they are, one after the other, moving along, 11 footprints in total, going all the way back to the back of the quarry.
They're enormous. These are a bit bigger than an elephant, easily.
It is. They're three-toed dinosaur footprints. Again, just like a bird, splayed out and with claw marks. So if we place the cassowary's foot into the trackway, instantly you see some amazing features that are similar. Big long toes with big claws on the end of them. This is exactly what the theropod trackway had. And the scales, look at those scales, they're so dinosaurian, it's amazing. So when you trace out this animal's foot, you can really see that this would have been what the animal's leg would have looked like, just much bigger. Isn't it amazing? I mean, we are looking at a dinosaur foot right here and a dinosaur footprint. This is today, that's 100 million years ago.
Yet another link between the cassowary and the dinosaur ancestors, but it's a pretty sobering thought, isn't it? The last thing we find in the dissection is that this road traffic accident didn't just kill this individual female, it wiped out potentially future offspring, future cassowaries, and if we don't protect these animals and stop them dying, we run the risk of losing the closest living relative to the dinosaur.